Can't do it.
Can you do 105?
Why not? Because. Next question. See what a ridiculous answer because is?
Or because I said so?
Was it secant or cosecant?
That's what my mom does, and I said, that's not an actual explanation, you do realize that, right? It worked when I was younger, it doesn't work anymore. But then I use it with like Maya.
That was
Yeah, I do
65,
too.
right?
Like
Okay,
everyone's-
so tell me about it. Do you like cosecant? Shh.
No.
What would you do?
Sine.
So,
So inverse sine.
inverse sine of 2.
Not possible.
What's the inverse sine of 2?
Not possible, you can't.
Right. Done.
Oh, I thought that. Because in the other problem we did, right, where it's like cotangent and a. Okay. Because like, they said before, like when the inverse is on the inside, you cancel out
And that's basically what happens as long as it's possible. Yep. So if it clicks to you right away, you're good. If it doesn't click to you and you go to there, then you'll be good there. Yep.
Can you do 105?
There we go. I'm not reading all of this.
Oh, I think
Oh, God.
Okay. So, I is current, capitalize maximum current, T is time in seconds, F is frequency in hertz. Hertz, by the way, is number of cycles per second. Hertz is basically 1 over seconds. Doesn't really matter, but just something that might come up in your studies at some point. Okay. Frequency is 5 hertz. That's F, right? Maximum current is 115 amps. Capitalized maximum current. What time t corresponds to a current of 85 amps? That's little I. Okay? So I equals I sine of 2 pi ft. So what can we fill in? Little I is 85. Big I is 115. Sine of 2 pi times 5 is F times T. So sine of 10 pi T.
Yeah.
What are we trying to do?
So
Find time. Trying to solve for T. Step 1. Divide the 115, so 85 over 115 equals sine of 10 pi t. Step 2.
inverse sine.
Can we divide here? Is there anything to divide by? The problem is that we're looking for this, aren't we? What does this represent? Sine of 10 pi t. What does 10 pi t represent? An angle. So the reality is, we're asking ourselves, what angle? what angle
This is a sine,
has a sine of 85 over 115?
so inverse sine.
So inverse sine. When we're asking ourselves what angle, that's what we're doing. So the inverse sine of 85 over 115 equals 10 pi t. Write that into your calculator, right? Inverse sine of 85 over 115. By the way, all of these questions, any question like this is going to be a radians thing. Let's see, I would guess I would put it in the 55-degree range. It's going to be a little less than a radian. So 0.9 something,
0.831.
831. How's this
Well,
work?
what, 0.832.
Okay. 0.832 equals 10 pi t, and then divide by 10 pi, which is 3.14, so 31, a little more than 8, a little more than 2, so a little more than 1/4, 0.27-ish. Rats. 0.26. 0.26 what?
Oh, 1/3.
0.26 what?
Oh, second.
Second. Okay? Anything else? Okay? Band-Aid's falling off. What'd you do?
I just put it back on.
Mad. What'd you do to your elbow?
Oh, I just dumped it.
Huh?
I just stripped it.
Oh. Okay, we're going back. Something that we did probably almost 2 months ago. That should be easy then, shouldn't it?
Triangle.
133. All for me. Thank you.
Let's do it. Did you what about this?
All right. Welcome to the final chapter of Honors Algebra 2. Final chapter.
What did you do?
Which means that after today, the next time I start a new chapter, it'll be with the new recruits. Huh?
You made it sound like you're in the
Why are you so racist?
I'm the drill sergeant, right? Wow, last chapter. All right, we get to solve the triangle. So, let's do this. Oops. So when we start to get information, and by the way, what does solve the triangle mean? All the angles, all the sides. So how many things are we going to have to find here? No.
3.
3, because we already have 3.
6.
This is that high-level math stuff, I know.
Okay, wait, is that a right triangle or is it just a triangle? It's just a triangle. Okay.
So we have 3, we need 3. Let's label the triangle first. Is that a big deal? We just put A's, B's, and C's wherever we want, right?
Yay.
What do you mean?
Well, you have to put
Let's see, if we say that that's angle A, that's 68 degrees. That's 2 and 6. Is there anything that we have to do? Side A opposite, like over here? And so that would be 12. That is the only key here. The sides and the angles with the same letter must be opposite one another.
Wait, why is it 12? Oh.
I gave it
C
to
is
you.
12 degrees.
Angle B, can I put angle B there?
Yeah.
Why the heck not? That is 36 degrees. So that would make this side C, or angle C, which would make this side C, which would make this side B. We okay with that?
Yeah.
Okay, Sophia came up with the bad news already. What's the bad news?
It's not a right angle.
It is not a right triangle. Could we have figured that out without me telling you?
Yeah.
Okay. When we have a non-right triangle, now I don't like saying non-right triangle, so we're going to use a different phrase for it. We're going to call them
Obtuse? Obtuse.
non-right triangles are called oblique triangles. So if we have a non-right triangle, an oblique triangle, what are we no longer able to use? 2 things. One is the Pythagorean theorem. Pythagorean theorem is out. Is there anything else? Trig stuff.
Yes, sine cosine.
Going somewhere?
I walk into.
Class. No.
I walk in and the first thing
What
I hear
else
is
can we
trig
not
stuff.
use besides Pythagorean theorem?
Oh, the, isn't it like the square root 3 over the sides?
It's a word that's kind of made up.
Neither of those words are
No, we've been using them in trig so far.
So wait, it's 8.1a.
Come on. Right triangles, Pythagorean theorem we can't use because that's in a right triangle. What else can we not use because it's not a right triangle?
Alpha? No.
9-letter word that we kind of made up ourselves.
9?
Did you? Oh. I believe you, you just gotta shout it out. Remember, you're right most of the time. Can't use SOHCAHTOA either. That's why we liked right triangles, because they were much easier, because we didn't, we got to use all those things. So since we've lost 2 tools, we need tools to replace them. And the first of those tools, the one that we're going to talk about today, is the law of sines. You guys have seen that before. Yeah, this is a really hard formula to know. This says sine of A over A is equal to sine of B over B.
So hard.
I don't know if I'm going to be able to handle that one. I know, we'll get to that Monday.
Oh no.
Okay, I can't have the constant chatting at the tables. I know what we can do. We can switch up all your tables.
Wait, hold on.
Well then,
Hold up.
pardon my French. Shut up. Not
gonna work.
Okay, it's like we're getting back into the I keep having to quiet everybody down every time. And I feel like doo-doo right now. So don't make me do that, please. Okay? In an oblique triangle, which angle is the biggest?
The one opposite.
A, B, or C?
I mean,
We have no idea. Could it be A? Could it be B?
Yeah.
Could it be C?
Yeah.
Which side is biggest? We don't know that either. So because of that, because A, B, and C are basically interchangeable, okay, we need to include C in this law of sines also, and so it goes just as you would hope. C equal to sine of C over C. You can use any combination of this that you want. You can do sine of A over A equals sine of C over C. That's totally fine. I can't hear a word you're saying. Okay. There is one key when we're, next one, there you go. There is one key when we're using the law of sines, and that is that we have to have, what do you think we have to have?
So,
Well, here we have two angles and a side. Could we have two sides and an angle? Sure. What do we need to have? Three pieces of information, and two of those pieces have to be the same letter. Have to be the same letter. We have to have an angle and a side A, or an angle inside B, or an angle inside C. We have to have two things that are the same letter, otherwise we can't use law of sines. Okay? In this case, do we have that? Okay, so can you set up law of sines for me with this problem? Sine of 68 degrees over 12 equals sine of 36 degrees over
B.
B. Why'd you pick B?
Because that's
Because it's angle B. If it's angle B, it's got to be side B. What do we do now? Cross multiply. B sine of 68 degrees is 12 sine of 36 degrees. So what do we do now?
calculator.
Divide by the sine of 68 degrees. So B equals 12 sine of 36 degrees over the sine of 68 degrees. What do we do now? Calculator it. I would strongly suggest that you make sure that you are in degrees mode. If you are not in degrees mode, you will get something that is very bizarre or very strange or just wrong.
Won't work. Oh, my battery's low.
So B equals 7.61. Cool. Now I will tell you that this is not the order I would have done this. Because what were we given at the beginning of the problem? Two angles. If we have two angles, we just get the third angle. How do we do it?
Add the two and subtract it from
Subtract from 180. So we got 104 from 180 gives us 76 degrees. Are we done? Why not? Side C. So talk to me about side C. Sine of 68 degrees over 12. Now, you used A again. Why'd you use A? Why not use B? So that's right, I remember we talked about this. We're going to go back to what we had talked about earlier in the chapter, which is if possible, do not use rounded numbers. If possible, don't use rounded numbers. It won't always be possible to not use rounded numbers. But if we can avoid it, that would be good. So you did sine of A over A equals sine of 76 degrees over C. C equals 12 sine of 76 degrees over the sine of 68 degrees. Plug that into our calculator. Now are we done?
Yeah.
Now we're done. We have all the angles, we have all the sides, life is good. Cool. Questions? Okay. So, we talked a minute ago about what we need to have to be able to use the law of sines. We said we need 3 pieces of information, but more importantly, 2 with the same letter. So if we were given, so in this case, what were we given? 2 angles and a side. So 2 angles and a side. Was that side in between the 2 angles? Was the side that we were given in between the 2 angles?
No.
No, it wasn't. So because of that, by strict definition, that would be AAS. But the reality is, if we have 2 angles, we really have all 3 angles, don't we? So we'll see this more often. We won't see it written as much as AAS. We'll see it written more as ASA, which is what you wrote last year. Okay? But a reminder of what we need to use the law of sines. So if we were given SSS, how well would that work for the law of sines? Because 3 different letters. We don't have an angle and a side with the same letter. So we're not going to be able to use law of sines when we have SSS. We're going to need another tool for that, which we'll get to on Monday. What about if we had SAS? That is side angle side. Would that work?
The sides have to be this. Oh, wait a minute.
Actually, you can find the other side, so.
So SAS, side, angle, side. Which side would the side be? It would have to be C, right? Because SAS means that the angle is in between the 2 sides. So if we're taking this side and this side, we can't take this angle. Try that again. If we're taking this side and this side, we can't take this angle. If we're taking this side and we have SAS, we have to take the angle that's in between. Does SAS work okay for law of sines? No, because 3 different letters. Side A, angle B, side C. No way to get this to work. So both of these are going to need a different tool, which, like I said, we'll talk about on Monday. What about A?
No.
What do you mean, no? I don't know what that means. Did you use AAA at all last year? No. Any idea why? Let me ask you this. Let's say that we had a triangle, and we were given AAA. The first angle was 60 degrees, the second angle was 60 degrees, The third angle, therefore, was 60 degrees. Tell me about the triangle. Okay?
The length could be
The length's what? The lengths could be anything. Right? We could have a 60, 60, 60, an equilateral that's like tiny. Or we could have one that's huge. If we're given the measures of the angles, what do we know about the size of the triangle? Nothing. Which is why you never use this. Because this is useless and irrelevant and there's nothing we can do about it. Okay? So AAA just will never happen. So, we talked about ASA over there. We talked about SSS, we talked about SAS. There was one more we have not talked about yet, and that's because you didn't really use it last year. Because it was bad. And it was SSA. But your teachers probably said something like, they might have rearranged the letters and said, it's a bad word.
Yeah.
And you can't use it if it's a bad word, right? Yes. Mhm. Would SSA work in the law of science?
No.
No, yes, it depends. You kind of hit every answer there. You have side. But what angle could we not use in SSA? We could not use angle B. Because SSA is saying that the angle is not between the two sides. The angle is not between the two sides. So we could use either of these two angles. So let's say we picked that one. Would that be okay for SSA? I'm sorry, would that be okay for law of science? Yeah, it would. So, let's do an SSA problem. Let's say that A is 5 and B is 9 and angle B is 84 degrees. The book might use beta. I've kind of always done B's here, so. But if you want to call it beta, alpha, beta, and gamma, that's totally fine. Gamma would be the third letter in the Greek alphabet. It looks like this. It's a what?
It's a sideways alpha.
Yeah, kind of. That's kind of the way I draw it. It's in the book. It would look differently, I'm sure. All right. Can we set up our law of sines? Might want to draw the triangle first. Let's see, 84. That's probably close to 84, so we'll do that. Which means we'll call that D. Then what? So down here, you set across, so like that. Okay, anything else? Where are you going to put A? Okay, put it there, and we'll make that 5. Okay, what else? Angle A is down there, which makes this angle C, which makes this side C. Ready to rock? Tell me what to write. Sine of 84 degrees over 9. Sine of A over 5. Yeah, we can. I'm going to simplify it a little bit. I'm just going to multiply by 5. Since what we're looking for is in the numerator, if we just get rid of this, we'll be done. So that would say that sine of A is equal to 5 sine of 84 degrees over 9.
Inverse. Oh.
Now what? Calculator. 5 sine of 84 over 9. Which will probably be about 0.5.
0.55.
0.55. Wow, that's really close to 1 then. Give me 4 digits if you would.
0.5525.
Thank you.
Inverse sine.
So sine of A equals 0.5525. And so now we'll do the inverse sine of that, which will get us somewhere in the 30-something degree range.
33.54.
Because what is this saying? The sine of some angle is 0.5525. So what are we trying to find right now? Which is an angle. Right? We're trying to ask what angle has a sine of 0.5525. Right? And whenever we're asking the question, what angle, that's when we're doing that. So the inverse sine of 0.5525 gives us an A of, what'd you say, 33 point, give me one decimal.
5. Oh, 5.
5? So we know that angle A is 33.5 degrees, which therefore means that we can also find angle C. That's 117.5, so 62.5 degrees for angle C. Are we done? Because side C, tell me what to write.
Sine of 84
Sine of 84 degrees
over 9.
over 9. Sine of 62.5 degrees over C. C equals 9 of 62.5 degrees over the sine of 84 degrees. Point 7-ish divided by almost 1 plus 7 point something.
8.03.
8.03. So C is 8.03. How are we doing? Cool. Questions so far?